Hi students, welcome back. Let's continue with the classification of routing protocols. We are discussing the different routing protocols for ad hoc networks. So in the previous video I explained about the first one, that is it is based on the routing information update mechanisms. We are discussing the table driven, that is a proactive. Okay, so the proactive routing protocols. So in that I explained about DSDV. Now let's see what is this WRP. So in each and every protocol, I'll just take two examples. So the first one is the table driven, next on demand, next is a hybrid. So these three comes under the based on the routing information update mechanisms. So these are the update mechanism. So in each and every protocol, we will take two examples. So in the previous video, I explained about DSDV. Now let's see about the WRP. What is this WRP? WRP is the wireless routing protocols. So we call it as a wireless routing protocols. So what these wireless routing protocols will do? Here each node maintains 4 tables. Okay. So in wireless routing protocols, each node, whatever the node that is present in the networking, that node will maintain 4 tables. They are saying 4 tables. So one is the distance table, next is the routing table, and another is the link cost table and message retransmission list. So total 4 tables that will be maintained by each and every node that is present in that wireless routing. So what is this distance table? The distance table containing network view of the neighbors of the node. So it's just containing the network view of the neighbors of the node. The distance and predecessor nodes for all the destinations as seen by each neighbor. So whatever the here in the distance table, it containing a network view. So here the distance and the predecessor nodes. Okay. So the predecessor node for all the destinations as seen by each other. Means the node that is present here, suppose this is a 2 and the predecessor, this is a 1. So here the distance and the predecessor node for all the destinations as seen by each other. Suppose X is the destination. So from here, what is the distance? And from here, what is the distance? So everything will be maintained in the distance table. Okay, so whatever the node that is participating is itself is acting as a destination, and it has to reach the final destination. So what is the distance between the present destination and the final destination? Next is the routing table. The routing table containing view of the network for all known destinations. So it including the shortest distance to destination, the predecessor node, the successor node, flag indicating the status of the path, that is a correct, loop, null. So everything will be maintained in the route table. So the route table contains the short distance of destination. So to destination, what is the short distance? So that node has to be written here. And the predecessor node, that is a before node, and the successor node means the next coming node. So everything will be maintained in the routing table. And the next one is a link cost table. So I said the wireless routing protocol is having 4 tables. Okay, distance, routing, and the link cost table. The link cost table containing the cost related information. So it is explaining about the cost, means how much cost that it takes from passing from one node to another node. So you need to take the minimum cost. So this link cost table containing the cost related information, including the number of hops to reach the destination, the cost of broken link, you call it as infinity. Suppose if you are calculating the cost related information over the hops to reach the destination, suppose at any place the link may be breaked. So the cost of the broken link, you have to be take it as an infinity. The number of updated periods passed from the last successful update of the link. So that information will be stored in the link cost table. Now let's see the next table, that is a message retransmission list, MRL. Message retransmission list containing counter for each entry. The counter is decremented after every retransmission of the updated message. So what information this message retransmission list contains? the name itself is saying it is a retransmission list. The counter is decremented after every retransmission. So whenever the retransmission, when this retransmission will be occurred, whenever the link is broken. Okay, whenever the path is broken, then only the retransmission will be done. So the counter is decremented after every retransmission of the updated message. So these are the main 4 tables that are present in the wireless routing protocol. So now I want to explain how I'm taking a simple example to explain how this wireless routing protocol will exist. Let's see the example. So here I'm taking the nodes as 1, 2, 3, let's take 4, 5, 6, 7, okay. So this is a network I'm taking. So 1 is a source, and let's take 7 is the destination. The cost for the link on the links is, so these are the cost on each link. Okay, so here the routing entries at each node for destination 7. Let us take what are the routing entries. Routing entries at each node. I'm taking it as at each node. So you have to calculate the routing entries for at each node, whatever the node that is there, you have to take each node. For destination 7, we have to reach the destination 7. Okay, so how it is? Let's take the table. Destination. The next is nothing but the successor. So I said here it consisting of 2. One is a predecessor and the successor. Successor here is nothing but the next node. Predecessor, that is a before node, and the cost. So let's see how the table will be. So let's start with the 7. The destination itself 7. Let us take the reverse topology. Means we starts with the 7. If the destination is 7, what is the next node? Because this is a destination, so there is no next node for this 7. And the predecessor is also the 7. Because why I'm saying it's predecessor, we don't know from where it is coming. So if you complete the table, then we can know. So it is coming from 2 or 4 or 3. Means 2, 4, 5 like. So that has to be decided further. So if you take the 7, the predecessor itself is a 7 and the cost of this is 0. Now let's take the 6th node. Let's take this is as I'm taking, you can take your own, okay. So whatever the node you want, you can take that node. So I'm taking 7, 6, 5, 4 like that. So if you take the 6th node, so what is the successor? Means the next node. So the next node of the 6 is, you have to take 3, because here 5 means the cost of the 6 to 5 is 7, but here this is a cost is less. So let's take the successor. The next node is 3 and the predecessor. So the predecessor, obviously it is coming from this route, because here only 2 links are there. So if suppose if comes like this, it has to follow 4 links, and this is a long distance. We need to take the shortest distance. So the predecessor, from where it is come, so it is 5. Now the cost of the link is, the cost you need to calculate it to destination 7. So the 6 has to reach the 7. How it is going to reach the 7? So calculate the shortest distance. Okay. So if you go like this, 4 plus 1, 5. 5 plus 3, you will get 8. Okay. So if you go like this, you will get 10. So 8 is a short when compared to the 10. So just take this path. So it will take this path. So the cost is 8. If you take the 5 as a destination, so obviously the successor is 7 itself. Means from 7 it is coming, and the predecessor, the before number, is 5 itself. And the cost is 3. If you take the 4, obviously the successor is 7, because that is the destination, and the predecessor is also, it is 4 only, because from 4 it is coming. So 4, and the cost is 2. If you take 3, so see here, if you take 3, what is the successor, the next node? I have to take 4 or 5. You have to take 5 because the cost of the distance from 3 to 5 is 1, but here it is 3. So you just take the successor as 5, and the predecessor means from where it is come, from 7 to where it is come. Okay, so this is the cost. Here is 2 plus 3 5, and if you come like this, 3 plus 1 4. Okay, so better take the 5 as a predecessor, and the cost is 4. So in that way you need to be calculated the each and every node. So this is how the wireless routing protocol will be occur. Suppose when a node detects a link break, let us take at any position the node detects a link break. So let us take this, a break is occurred from the link 7 to 5. So whenever it occurs, so only the sum table will, all the nodes will be same, but only the nodes that are participating in this direction, those nodes will change their route. Okay, so here the 6, the successor is 3 only, but instead of predecessor 5, okay, it takes the predecessor 4. Okay, it's just take the predecessor 4, and the cost will be increased to 9. So like that the table will be changing. So the point that you have to remember here is, it sends an, whenever the link is break, it sends an updated message to its all neighboring nodes. It sends an updated message to all neighboring nodes with a cost of infinity. So whenever it is break, that line is break, it intimate to all the neighboring nodes with a cost infinity. Okay. All affected nodes updated their route when they receive updated message. So whatever the affected node, so here whenever the 5, this line is break, this is affecting, this is affecting, this node is affecting. So here these all 3 nodes are affecting. So whenever these nodes are affecting, okay, then their routes receive update messages. So those routes are all receives the update messages. The node that initiate the update message finds an alternative route from its destination. So it's just whenever their update message is received, obviously it finds for the next alternative route. So it updates the routing table and sends the update message to its neighbors. The nodes updated its routing table if this received route is better than they have, otherwise they is discarded. So this is a way you have to be maintain the routing table for the wireless routing protocol. Thank you.